All right, 11.5, the last part we're doing is over the binomial theorem, okay? So when we're determining the binomial theorems, and this is the important part, binomial, remember the bi means two. Here we have two terms, and it's raised to some power. So we're doing the basic one, a plus b raised to the second, or squared. It's the same thing as saying a plus b times a plus b. You do your FOILing, you get this term. But when we have terms that are larger than that, you're going to have more. There's a few things here that you should know. If it's raised to the 0 power, that's always equal to 1. If it's raised to the first, you're going to have 2 terms. If it's raised to the second, you're going to have 3 terms. 1, 2, 3. Raised to the third, you're going to have 4 terms. So it's always going to be one more term than you anticipated. Okay? The other thing that you need to know is we don't have to do the FOILing of all of these sections in order to get this. We can use Pascal's triangle. So if you don't remember what Pascal's triangle is, it starts with a 1 and it goes a 1 on each side of the tree. In the middle, like on this one, you have a 1 plus 1, that equals 2. 1 plus 2 is 3, 2 plus 1 is 3, 1 plus 3 is 4, 3 plus 1 is 4, 3 plus 3 is 6. So notice that this correlates to the ones, the coefficients over here. Here's our 1, here's our 4, 6, 4, 1. 1, 5, 10, 10, 5, 1. They match. So we don't have to do the FOILing, we can just use this. A few things that you should know are listed here, and I already kind of went over some of them. And the other thing I want you to notice, and I just noticed it here, but it's a good point to bring out, is I want you to notice that as we start with our first term, here's a to the third, right? Because you have a to the third power. Notice as I go to the right, my a's decrease. I went from a to the third to a to the second to a to the first power to a to the 0. But remember, a to the 0 is just 1. So it's actually just gone. Notice what happens to the b. I'm adding a b. Here's a b, b squared, b to the third. So if I were to add up the exponents of my 2 terms combined, it's always going to remain at 3. Here I have 3, the exponent is 3. 2 of these plus 1 of these, that's 3. 1a plus 2 b's, that's 3. And then b to the third, there's 3 again. Let's try it with the 5s. You have 5 a's. Here you have 4 a's and 1 b. The exponents add up to 5. 3 plus 2, 5. 2 plus 3, 5. 1 a and 4 b's, that's also 5. And then 5 b's, that's of course 5. So these are some really neat tricks that you'll be able to look at when we're actually solving for this. Okay, so what I'm going to do here is going to be slightly different. Instead of going ahead and expanding on this, we're just going to go ahead and expand on this one. Let's go ahead and write down what the 6 terms would be. I would have a 1 here, add these 2, 6, add these 2, 15, 20, 15, 6, and 1. See, all I'm doing is adding to Pascal's triangle. The next one, this is n is equal to 6, and here will be n is equal to 7. Okay, I'm going to add a 1 here. These 2, 7. 6 plus 15, that's going to be 21. 35. 35 again. 21. 7. And then 1. So when I come down here, when I'm expanding it, and notice that this is to the 7th power, I'm going to use these coefficients. I'm going to start off with a 1. So I'm going to start off over here, way over here, because you're going to need the whole length of the paper. I'm going to say, all right, so this is going to be 1. This is going to be the first term, so it'll be a to the 7th. So 1, a to the 7th. No b's, not yet. Okay, so when I go over to the next term, I'm going to say plus. I'm going to use this coefficient, which is 7. I'm going to reduce my a's and add a b. So I'm going to have a to the 6, b. Okay, next one, plus 21, a to the 5th, b squared. Always make sure that your exponents on your variables add up to the 7. Okay? Plus 35, a to the 4th, b to the 3rd, plus another 35, a to the 3rd, b to the 4th, plus 21, a squared, b to the 5th, plus 7, a, b to the 6th, plus 1, b to the 7th. I ran out of a's because this one is taken away and I added one more b, so that's where you're going to end up. So this, instead of me foiling it, I can just use Pascal's triangle to find out every single one of these terms. Now, the rest of the lesson, we're going to be using it so we can find specific terms. If I wanted to know what this term was, I can use a formula in order to find the actual number. Because remember on here, our coefficients are still 1. It's not always going to be 1. We're going to have like a 2 and a 4 and a 6 and different numbers, different coefficients other than 1. That means that these numbers are going to change. And I'll show you how to do that on the next parts. Okay? Let's do that here. All right. So binomial expansion. When we're doing these, we are going to be using what we call combination. Okay, and remember the n is going to be the first one, which is 4, which is 4 factorial, over r, which is 2 factorial, and then another 2 factorial. In other words, what this means is 4 times 3 times 2 times 1, and this is going to be 2 times 1 times 2 times 1. If I have it like this, you can see that the 2's cancel, the 1's cancel, the 2 goes into the 4 2 times, and all I'm left with is 2 times 3, which is 6. See, we don't have to do all this. Let's just use the calculator. So let's go ahead and do the number 3 going across. We're going to start with 10, PRB, combination, 7. We have 120. Notice over here, it's going to be 10 divided, 10 factorial, and then it's 3. Well, guess what? If we're using the formula here, it will be 10 factorial, 7 factorial, 3 factorial. This one here would be 10 factorial, still in the top, but now it would be 3 factorial, 7 factorial. These two actually end up being exactly the same. Well, let's just check. I'm going to go up because it's the same number 10, and now I'm going to use the 3. Exactly the same. This explains why when we do our first one, you can see that they are actually symmetrical. So you have a 6 here, you have a 6 here, you have 21 here, you have 21 here, 7, 7, and so forth. Because when they switch, so do the numbers are going to be exactly the same. Okay, let's go ahead and do this one. I'm going to do 5, PRB, choose 0. Okay, and here you can see the 1. Now this is an important one because this is what explains the ones on this side. So if we have 0 B's, it's going to cause it to be just 1. So here's going to be 1. And the same thing if you choose all of them. If all of them here has 5 B's and no A's, it's saying 5 out of 5. That's also going to be 1. I'm going to use it up here again, and I'm just going to change the second number to a 5, and you can see that that also equals a 1. That's why all of the 1s are on both sides. Okay, so let's keep going here. I'm going to do 5, choose 0. So we're going to do 5, 0. Okay, and then I'm going to choose the first term. So here it's going to be 3y to the 5th power. And then you can put the 2z to the 0 power, but that's going to end up being 1. So I'm not going to even put that here. I'm going to go on to move to the next one. I'm going to say 5, choose 1. Okay. And then here it's still 3y, but remember this is now to the 4th power. And we have 2z, and we just have one of those. So notice here, you still, if you add up these two exponents, you're going to get your 5. And here you get your 5. Then we're going to go ahead and do 5, 2. We're going to have 3y to the 3rd power this time. and then 2z squared. Okay, add them up, you got your 5. Keep going, plus 5 choose 3, and then it will be 3y squared to the second, and then 2z, and then it was 2, so we're going up to 3 here. Okay, still 5. We're going to go ahead and add some more, plus 5 choose 4, 3y. This is 2, so this is 1, which means 2z is going to be raised to the 4th. I'm going to go ahead and put the 1 here so you can see that they still add up to 5. Plus 5, no y's, but we do have 2 z's, and this time we have 5 of them. So we're going to go ahead and use our calculator for this part of it. Okay, so let's go ahead and do that. 5 choose 0, remember that's equal to 1. So I'm basically taking the 5, the exponent, and applying it to both of these. It needs to be 3 to the 5th. I'm going to go ahead and do it here. 3 raised to the 5th. That's going to be our first one. This will be 243. And then don't forget to add the y to the 5th. So y to the 5th. Plus 5 choose 1. Let's do that in the calculator. 5 PRB choose 1. That's going to get me 5. So I'm going to put a 5 here. Times 3 to the 4th. 3 raised to the 4th power. That's going to be 81. And then you have 4 y's. And then you have a 2 here. So I'm going to also multiply this by 2z. Okay. So what I'm going to do in the next step, or actually I'll go ahead and do it now. I'm going to do the 243y, almost forgot the 3, 243y to the 5th, plus, and I'm going to multiply these 3 coefficients. It's going to be 5 times 81 times 2. Here I'm going to get 810 y to the 4th z. Okay, that's how we're going to do all of these. Let's go on to the next one. Plus 5 choose 2. So I'm going to just scroll up to there, and I'm going to go ahead and add this to 2, and here I get 10. So this is going to be 10. 3 cubed is going to be 27 y to the 3rd. 2 squared is going to be 4 z squared. Okay, now I'm going to multiply all these together. 10 times 27 times 4, you're going to get 1080 plus 1080 y to the 3rd z squared. Okay, let's go on to the next one. 5 choose 3, go back up. Here we go. 5 choose 3. We get 10 again. Remember, it's going to repeat. So we're going to go ahead and do 10. 3 squared is 9y squared. And then 2 to the 3rd is going to be 8. And then you have z cubed. So let's do those together. 10 times 9 times 8. We get 720. So here I'm going to have plus 720 y squared z to the 3rd. Okay, now I'm going to go ahead and do these two. So go back up. 5 choose 4. You get 5. I'm going to go ahead and squeeze that in. I'll do it right over here. This is going to be 5 times 3 y times 2 raised to the 4th. That's going to be 16. This is going to be 16 z to the 4th. So let's go ahead and multiply all those coefficients. So 16 times 15, you're going to get 240. So plus 240 y z to the 4th. Okay, one more. This is 1, so it's basically 2 to the 5th power. So 2 raised to the 5th power, that's going to be 32. So here I'm going to have plus 32 z to the 5th. 32 z to the 5th. That's this part here. This is going to be 1. This will be 32 z to the 5th. And just add it on to the bottom. So now you have the entire the entire factor without having to FOIL it yourself. All right, let's go ahead and expand this next one. This next one is saying expand using the binomial theorem. We're going to do here a same. Notice that this is a 1, and now this is squared. Over here you have a -5 as your coefficient, but the z is not squared. Let's go ahead and do this one. Okay, so the first thing I'm going to do is use the first entire term, and in this case it's going to be y squared, and I'm going to raise it to the 4th power, so it'll be raised to the 4th. Okay, plus 4, this is a 0 term, so 4 choose 1, that's going to be our first part, y squared to the 3rd. Remember, you subtract 1, but then you're going to add that -5z, and you're going to say add 1. So this is going to be raised to the 1st. Plus 4, 2, y squared. You had 3, now you're going to have 2. And then -5z, you're going to add 2. So these two exponents have to add up to 4. Let's do another one. Plus 4, choose 3, y squared. Now we're down to one of these, and we're up to 3 of the z's. Okay, plus one more, 4, 4, which is always equal to 1. You don't have any more y's, but we do have 5z to the 4th. Okay, hopefully that is a little bit easier to read. Okay, now let's just do the math. Remember, when you're doing exponents and you have an exponent raised to the exponent, you're just going to multiply this, so it's going to be y to the 8th. Okay, plus, let's use the calculator for the second part. 4 choose 1, 4 choose 1 is going to get you 4. Here it's going to be y to the 6th times -5z. Okay, we'll simplify it in just a little bit. Plus 4 choose 2. Let's go ahead and go up. 4 choose 2. You have 6. Multiply y to the 4th, and then square. -5 squared is going to be 25 z squared. Okay, so now we'll simplify this soon. Plus 4 choose 3 is going to be 4 y squared. -5 cubed is going to be -125 z to the 3rd. Plus, this is always 1, and then we're going to do the negative. We're going to do 5 raised to the 4th power. It is negative, but it will remain a positive value. So 625z to the 4th. Okay, let's go ahead and simplify it. Y to the 8th plus multiply those two numbers. 5 times -5 times 4. That's going to be a -20. So I'm going to change that to a -20. Y to the 6th z. Okay, plus 6 times 25, that should be 150. So we have plus 150 y to the 4th z squared. Okay, let's keep going. We have a minus, so 125 times 4 is going to be 500. So minus 500 y squared z cubed. Okay, plus 625 z to the 4th. Okay, this is going to be the answer for this problem. Okay, notice that in this particular case we cannot be using and adding up the exponents here just because these exponents don't match either. So just be careful when the exponents don't match, it's not going to add up quite the same. Alright, let's go ahead and use this formula right here. This is the actual formula that I have on the formula sheet, and I'm going to show you that it is the same one. So here is n choose k minus 1, a, n, b, k minus 1. So this is the formula that I prefer to use instead of that other one. This will get you to the exact coefficient that you're looking for. So if you can see here, it says find the 7th term of the expansion. Well, this is to the to the 9th. So what you're trying to do is, for example, if I had said find the third term of this one, I would be going 1, 2, 3. This is the one that I would be looking for, the coefficient. Okay. Here it's not asking us to expand it all together. It's just asking us to find a specific term. So let's go ahead and figure what that is. Okay. So in this case, the 7th term, that's going to be k. K is going to be equal to 7. N is always going to be the number on your exponent. So here you have a 9, that's going to be 9. Okay, so let's go ahead and use the formula. N, that's 9. K minus 1, that's going to be 6. Okay, K minus 1. A, okay, what is our first term? Our first term here is just X. So I'm going to have an X in there. And then I'm going to use N, which is 9, minus K minus 1. Well, remember this is K minus 1 too, so I can just say minus 6. So 9 minus 6. Okay. B is the second part of your term, which is in this case negative 3y. And then it's K minus 1. And remember, K minus 1 is just 6. Okay. So we're just plugging in these values. Right. Let's go ahead and use a calculator for that. I'm going to do 9 choose 6, 9, PRB, choose 6, and I'm going to get 84 here. Okay, this is going to be x to the third, negative 3 raised to the 6 is going to be a positive number, 729, y to the 6. Now we're going to multiply these two times 84, and I'm going to get 6, 1, 2, 3, 6, x to the third, y to the 6th. In this case, yes, the exponents should add up to the number that you have here because both of these exponents inside are 1. And you're done. Okay, so this is going to be a specific term in your sequence.